Okay, well, we're looking at trapezoids, and then a little later on we'll look at kites, but right now we're going to look at trapezoids. So now what do we know about a trapezoid? Well, a trapezoid is a quadrilateral, four-sided object where it has exactly one pair of parallel sides. The parallel sides are called the bases. The non-parallel sides are called the legs. And then we have base angles. Now, if a trapezoid is an isosceles trapezoid, there's some other things that we know. One, by definition, if the legs of the trapezoid are congruent, then we have an isosceles trapezoid. And if we have an isosceles trapezoid, then each pair of base angles is congruent. And if we have one pair of congruent base angles, then it is an isosceles trapezoid. One other thing that we know is that in a trapezoid, if it's isosceles, that's true if and only if the diagonals are congruent. So let's read what we got here. This is talking about cafeteria trays. It says to save space at a square table, cafeteria trays often incorporate trapezoids into their design. So we're obviously thinking about trapezoids. And if WXYZ is an isosceles trapezoid, and the measure of angle YZW equals 45, and WV, line segment WV equals 15 centimeters, and VY equals 10 centimeters. Find each measure. All right, so we know we're talking about an isosceles triangle. I mean, not triangle, trapezoid. Trapezoid. All right, so let's see. We're asked to find the measure of XWZ. But what do we know here? Now we know that the measure of YZW, which is this angle right here, that equals 45. And we're asked to find the measure of XWZ. And so we want to find that measure right there. So what do we know about an isosceles triangle? I mean trapezoid. I keep saying triangle. Trapezoid. Okay. Well, we know that each pair of base angles is congruent. Well, that would mean that this is going to have to equal 45. Okay, not bad. Now let's find the next measure. Measure of WXY. So which measure are we trying to find here? We need to find this angle. Okay, well, there's a couple of ways that we could go about this. One would be these two measures here, this measure and this measure, must equal 180. And so we could then simply just say that 180 minus 45 is going to equal the measure of WXY. And 180 less 45 is going to be 135. There's actually a second way we could do this. This is a quadrilateral, and this may become helpful later, which means that if we have a four-sided object, the measure of all the interior angles are 360. So therefore, if we're trying to find the measure of one, this angle here again, well, that would be 360 less the 45 that we know in this angle here, less the measure of the angle 45 of this angle here, over 2. Why 2? Because these base angles must be congruent. Now let me make this. This is congruent to that. So let's see, what's 360 less 90? That's 45 twice. Gives me 270 divided by 2, and shazam, that would be also 135. So depending on how I went about solving that, I'll come up with the same answer. That's good. I like that. That's kind of what I'm looking for. All right. Now, let's move on to this measure of the diagonals. So we're told that WV, we're going to ignore that phone, is equal to 15 centimeters, and VY up here, so WV is 15, VY is 10, and we're asked what is XZ. Well, we know, since it's an isosceles trapezoid, that the diagonals must be congruent. And so if this is 15 and this is 10, then XZ must equal 25. All right, and then it asks what is XV. So what is this section here? Well, it's going to have to equal VY. And so it also is going to equal 10, because this segment is going to be congruent with this segment, and this segment is going to be congruent with this segment by definition. And so there we go. We're using the properties of isosceles trapezoids to find measures of angles and line segments.